Howdy everyone, welcome to another episode of Devlogs. This is the final lesson for the 301 certification. Lesson 9 is unrelated to the certification and talks about setting up a fresh Unity project and how to integrate Wwise into your project and be set up appropriately. That'll be for a different video where I'll share the results of my exam and be moving on to a different project. For now, let's look at this table of contents. We have Advanced Music System, the two-piece music system, region music system, creating diversity using game parameters, and making an advanced music system. Disclaimer before we get into the lesson, I have yet to complete the Wwise 201 certification, and it hasn't been until the final lesson that it's recommended this certification be completed, before moving on to one of the 301 lessons. Luckily, I have a solid understanding of music structure and behaviors, so the only challenge for me will be learning potentially new interfaces or tools of Wwise, but that's pretty much been the vibe throughout all these lessons, so we should be fine. The lesson informs us that the Wwise Adventure Games music system is different from a more commonly known system. Usually in games, you enter a level and it has a musical theme for that level. However, this game's less traditional method tells us that when you enter a region, let's say the desert in this case, the desert theme will play. However, another type of theme can also play, that being the enemy theme, so both a region and an enemy theme can play at the same time. Each region in the game has its own container of music in Wwise, which plays specific pieces from those containers based on a few elements: the region you're in, whether you're outside or inside an active region, and the state of the player. Look at the instance below the picture it describes. In between the desert and village regions, the player is recognized to be outside of any of the music triggers. Because of this, a track called ambient plays. So the music changes based on what region the player is in, or if they're not even in a region. As for the enemy music themes, these play in correspondence to how close the player is to an enemy. Based on proximity, the volume will be affected in ways I'm sure you could guess, like how close the player is to the enemy and its attacks. The enemies also have 3 to 4 segments of music, which are complementary of the actions they perform. Imagine being blindfolded while playing this game, yet being able to dodge a spitting plant's attack because of the projectile's sound properties. The panning would let you know if it's in front of you or if it's going beside you, and its volume would tell you how close the projectile is. A cool note about the enemy and region music themes is that both were composed to be the same tempo and key, making them rhythmically and harmonically compatible during gameplay. These have also been hierarchically sorted in a clever manner within Wwise's Project Explorer. A music region switch container contains the region's themes, transitioning to the appropriate one depending on the player's location. Enemy themes are set up in a one-shot music playlist container, which I assume one-shot means it plays a single time, just how the enemy would perform an action a single time. In order for the enemy's musical moments to be synchronized with the music, their playlist container gets called from the music region's music segments. Because of this setup you see in the picture below, the lesson assures that enemy themes will always be posted in sync with region themes. The next note from the lesson is how states are going to be applied to music regions. This is being done with trigger colliders, just like in lesson 6 when we were using these colliders to apply aux buses to specified areas. Do you remember when I applied a flanger effect that played inside the wizard's house? A good example of how these states can be used is shared below, which I'll read. One example of using states to drive a music switch container is in the cave region of the Wwise Adventure game, where the ambient sounds, like the water drops, are explicitly meant to be observed. The presence of music here would make these sounds less noticeable, and so we set the music region switch to silent in the cave. All other music triggers are designed with the music in mind, and even when outside any music trigger, the subtle ambient theme will play. No matter the way in which you want to control music, the lesson suggests that states are an ideal way of doing so. In this first scene, we are going to change the state of the music for when the player enters the village area. To do this, we need to add a trigger for volume around the village and then a script that sets the on and off state depending on the player's location. The shape of the village from an overhead view is pretty spherical, so I'm just going to add a sphere trigger to the scene and adjust it to fit the region's proportions. I right-click a blank space in the hierarchy, and on the 3D Object Options side menu, click the sphere option. I use the Move, Rotate, and Scale tools in the top left of Unity to encapsulate the village area. Once sized correctly, I enable the Sphere Collider as a trigger by checking the Is Trigger checkbox in the Mesh Collider component. Later on, we'll disable the sphere mesh filter so that the collider is not visible during play mode, but to see things at work while running tests, I'm going to add a transparent red material to the object that we'll be able to see through. I do this by searching trigger_red in the project tab's search bar at the bottom. Once found, I drag and drop it onto the sphere game object. Now in the sphere game objects inspector window, I'm going to create a new script called setMusicState, which we'll use for setting a state to the sphere trigger. Moving into Visual Studio, you'll see our default setup for a newly created script, with our basic start and update functions. We are not going to need these, so you'll see me select all lines within the setMusicState curly braces and obliterate the text. In a blank space for a function, I'm going to make a void return and name the function onTriggerEnter. I'll then add our base class name that all Unity script derives from, monoBehavior. To complete the function, I add a private void return function named onTriggerEnter. In the parentheses, I put a collider variable named other. When the onTrigger function is called, it will be done alongside whatever was detected colliding with the collider, which in this instance would be the player game object entering the sphere trigger. With that being said, we only want this function called when the player enters the collider, but it would currently do so for anything entering the collider. We need the collider to identify when the player is entering the collider and when it isn't. To do this, we'll use what's called an if statement. In the words of the lesson, an if statement will receive an input, then evaluate it against a given condition, so that the programmer can execute a given piece of code when the condition evaluates to true. Otherwise, when the if statement returns false, it will skip the true segment of code. Inside the onTriggerEnter function, I type if parentheses other dot compare tag parentheses player, with a new set of curly braces for this if statement. Outside the function, I add a Wwise type state property called onTriggerEnterState. This state will be referenced in the if statement and needs a set value applied to it based on the conditions of the if statement. I type onTriggerEnterState dot set value parentheses and end with a semicolon. What this means is that if the player enters the collider, a state will be applied upon entering, which will be determined by what we put in the property drawer in Unity. In the property drawer for onTriggerEnterState, I put the Village Music Region state in the drawer, meaning the state, or rather the song, will be applied if the player enters the trigger. Listen to what happens as a result of what has been done so far. As you may have noticed, the state, which is the village's musical theme, has been applied when entering the collider. However, when we leave the village area, the music does not change back to the theme playing when we spawned in the training area. This is because we need to add another Wwise type outside of our function for an onTriggerExit state. Right beneath the onTriggerEnter function, I enter the same line of code, only I replace the word enter with exit. This also applies to the onTriggerEnter function as a whole. Watch as I copy-paste it and simply replace the words enter with exit. The functions are structurally similar, only I need the part I just added to apply a state for when the player is exiting the trigger. When I save my script, I can go back to Unity and find there is an onTriggerExit state property drawer in the component. I add the nowhere music region state to the drawer. Listen to the final results of this exercise. This is a suitable way for setting up enter and exit states for regions that do not overlap. That being said, what do we do for a system when there are regions that overlap? The top image shows how the village and woodland sections overlapping creates a scenario where the on-trigger exit function is making it so the nowhere region theme plays while the player is in the woodlands area. The system suggests that we can solve this problem by having a collective list of states that is monitored. Amongst these states, certain ones will hold priority over others so that the appropriate theme will play in the appropriate areas, even with overlapping regions. The bottom diagram shows the woodlands region overlapping the village, and the numbers indicate it takes priority over the village region's music. When the player enters the intersecting area, the woodlands theme will take priority in play. Let's go to a new scene in Unity and see this in action. You'll see we're given the village and woodlands region colliders, which are overlapping in the middle. We're going to add the set music state component we created in the previous exercise to both of the collider game objects. To do this quickly, you can either use Shift or Control to select multiple objects. Shift will select an initial object, then whatever you select apart from the first click will highlight everything in between. Control lets you click objects separately. With both colliders selected, I click Add Component in the Inspector view and add the Set Music State component. With both objects selected still, I add the Nowhere state to the On-Trigger Exit property drawer. Now is when I select the Village Game Object collider, giving it the Village State Music trigger. The Woodlands game object is given the Woodlands State music trigger. I will open Visual Studio and create a list of the possible state changes the player can cause during play mode. Under the Set Music State function, I type list and 2 angle brackets. Inside of these brackets, the type of property we are keeping track of needs to be given. I type ak.wise.state, which will keep track of the states put in the list. The list needs a name, and I go for a super fancy one. List of states. We want this super fancy list to be seen by other scripts, so I add a public access modifier at the beginning of this line. This far in, we have simply defined the name of our list. However, we need an actual list to list these states on. I do so by adding to the end of our line equals new list, with AKWise state in brackets. Then, I add parentheses at the end and end the line with a semicolon. I'm going to read from the lesson to break down what needs to happen next. In the previous exercise, you created 2 functions, onTriggerEnter and onTriggerExit. Although the same script is used on both the village and the woodlands trigger, the functions were given the private scope, and so each of these triggers will call their own instances of the onTriggerEnter and onTriggerExit functions. This will allow each music trigger with the set music state script to add the forthcoming state list independently. However, as the script is instantiated for each game object, how do you make sure all the scripts refer to the same list? The answer is the static modifier. By making a list static, only one can exist at all times. So, when referring to this list, all scripts will be looking at the same list. And there you have it. I couldn't think of a better way to break that down, and what this results in is me adding the modifier static in front of our public modifier. All scripts will now reference this list and no other. Before we create this list, I want to reiterate on how this will function with some visuals brought back up in the lesson. Our onTriggerEnter and exit function will be adding and removing states on this list, and whatever states are on the list will be given priority in some way. Between the numbers 2 and 3, this would be where the player is entering the woodlands area, yet is still in the village. Both states would be in the states list, except the woodlands state would be put at the top and given priority, and because of this, the woodlands theme would play. Beneath the onTriggerEnter function, I'm going to replace onTriggerEnterState.setValue with listofstates.insert. Inside parentheses, I type 0 onTriggerEnterState. The insert function does not overwrite elements in the list. It will instead move them downwards. To access these elements, I add a new line that utilizes the brackets and puts the element number inside of the brackets. This is where I use the setValue function so that states will be added to the list with a numerical value. I replace the setValue function with a .remove function, which will be for removing states on the list when our player is no longer within the collider of a region. To make the removal happen, we need to add the setValue function beneath the remove one and use our handy square brackets again. With our current iteration of the function, music will play and give priority to regions when a player is within intersecting regions. What this iteration does not account for is when the player is not in a region and the nowhere state needs to be applied. The lesson calls this a null reference exception. This is because while the function is trying to access a reference variable when there are none, it will then return as null during runtime. we are going to add a check function that checks for if there are any elements in the list. By recognizing when there aren't any, we can use what's called an if-else statement to determine what to do when there isn't an element in the list. In this case, it would be to apply the nowhere state region theme whenever elements are found to not be in the list by the check function. In order for the check function to properly be monitoring this, the function's curly braces need to be positioned between our set value function. I'll add a starting brace before this function, then one after it, so that it is keeping track of when there are or are not any elements within the list. Now comes our if-else statement. There is already something happening in the if part of this function, so we simply need to add the else part beneath the if function. I add the word else after the if statement's closing curly brace, then add the closing curly brace 2 lines down. The space in between is where our code will say what to do when there are no elements in our list. I type onTriggerExitState.setValue parentheses and end our line with a semicolon. Our onTriggerExitState is set to apply the nowhere region state in Unity already, meaning our code is done. Let's see this multi-stage trigger system in action. Does it get any cooler than that? The answer is yes. You better be excited. Pushing onward, we get into creating diversity using game parameters. We've been using states to do a bunch of cool things and have used switches and game parameters in the past, but now there's even more cool ways to use a game parameter. A cool example is to imagine that as you walk closer and closer to a waterfall, a harp begins playing louder and louder the closer you get to the waterfall, then it slowly dies out as you walk away. Let's do that, because it would be super cool. Here, you can see the waterfall's pivot points. The up-close pivot point represents the closest our player can get to the waterfall. Take note of this, as it will affect how we set up our game parameter and measure closeness and far awayness from our object of reference. I'm going to find the up-close game object within the waterfall game objects dropdown. Within its inspector view, I'm going to create a new script called setRTPC to distance, adding it as a component. And voila, we have a new script. Beneath our class, we're going to add a Wise type for real-time parameter control and name it GameParameter. We need to reference the game object's transform component's XYZ values, since we'll be referencing its distance from the player. These XYZ properties are defined as vector3, which you'll see me reference in the code. In the line below, I'm going to create the public property type for transform. This property will appear in the waterfall game object I have selected and will want it to reference where our player is and act accordingly. I'm going to name the property otherTransform, which I do for clarity's sake in informing someone that this property is referencing the transform values of an object other than the waterfall. With the transform position properties between each object being shared, we can calculate the distance between these two objects in our update function. I start by typing a distance function called vector3. In parentheses, I put in otherTransform.position. OtherTransform will later contain the player game object in its property drawer and provide its transform properties to be calculated for the distance between the waterfall and player. I'll add a comma and then provide reference to the waterfall's coordinates by typing transform.position. I end the line with a semicolon. Though the distance is now being calculated, we need to save the result. What's more, we need to save it as a float variable. Floats allow you to store values with decimals, which is important for solid transitioning within the real-time parameter control. In front of the line, I type float distance equal. This makes our calculations a float value each time the update function runs. Next, I'm going to map the game parameter to the distance value. In a new line below, I will set the game parameter as a global value for distance. All that's left now is to assign the parameters in Unity. After saving my code, Unity will update and we'll see new drawers appear in our inspector view. In the other transform property drawer, I drag and drop the player game object to provide a reference from the player to the waterfall's pivot point. Let's see the results. So the harp disappears when we get closer to the waterfall, then comes back as we walk away. I got that mixed up. My bad. Anyways, folks, that concludes the final lesson for the 301 certification, at least in preparation for the exam. Lesson 9 goes over integrating Wwise into a brand spanking new Unity project, which I'll be sure to use for a later devlog. As I mentioned weeks and weeks ago, I will be reviewing for the 301 certification exam by going back through the lessons and, most importantly, the videos. I stayed true to my word and have not watched a single video, meaning I have a way to challenge my understanding of the material. I'll be sure to share the results of the exam, obviously, and we'll then talk a bit about Lesson 9 and how I'll be moving on with this series. I have some ideas, all of which will be determined by school a little bit, but you'll see eventually. Anyways, thanks for watching. I'll see you in the next video. Have a good one.